Okay, welcome to Storing Data Using FHIR, a good idea, question mark. Please hold all questions to the end. This is a virtual presentation, so Grahame Grieve will be presenting remotely, and you'll see on the screens here. Or you could ask questions in Whova or at the end, like I said. Grahame, please take it away.
Hey, thank you very much. All right, I hear a nice echo. Go on, great. Oops, that's not the right screen. Let's share the right screen. Okay, you should all see my screen now. Get rid of Julep. Okay, storing data using FHIR. Is this a good idea? Now, first of all, about me. I'm the product director for FHIR. I was once an independent consultant, and maybe I will be again sometime, helping people exchange data with healthcare. I have a long history in healthcare IT. I was very much supposed to be there today, this week, hanging out to come, and then I got COVID 13 days ago. So bang, I couldn't come to USA. Sucks to be me. But anyway, hopefully you'll still find this useful and interesting. So for this presentation, I want to talk about why FHIR is not defined as a persistence format, but you can use it as one anyway, and you should understand the pros and cons of the approach, because there's some in either direction. Okay, so the question is, should I store FHIR resources as actual FHIR resources? And it's actually one of the most common questions I get. I've presented on it again and again. We still get questions on it again and again. And it doesn't have a simple or a single right answer. So this today is kind of like my stock answer expanded. And I hope that, I hope that it's useful. All right, so first thing to understand is HL7's main mission. HL7 functions in lots of ways like a vendor association. The idea is that vendors are free to develop their applications as they see fit, and all HL7 does is standardizes the interfaces between the applications. HL7 standards say nothing about what happens inside the application, and we never do, because it's entirely at the discretion of the vendor who chooses to implement the standards or not, as to how they implement the standard. And so HL7 lives in a world of black boxes with tightly described interfaces. Now, who are we kidding? HL7 standards say everything about what happens inside the applications, just not how it happens. And that was a dichotomy that I learned 25 years ago when I started working in this space. Because you have to be able to meet the interface, you have to be able to, this says a whole lot of stuff about what happens inside your black box. But nevertheless, HL7 standards say nothing about how you do what you do inside the application. And that's something that's basically true still. And it's a founding principle of FHIR. And our assumption is that there's always code between the database and that interface that does a bunch of things, including bridging between different views of the world. It doesn't mean that you have to be different. And of course, if you start from scratch in a new world, a greenfield application, you'll find this is what happens. I tell you, this is what happens. The business owner, the person putting the money on the table, says, do something quick and get it right. And of course, you can't do both. And getting it right would start by implementing the entire standard, which will never happen because you'll never, ever finish doing that. And so you choose some kind of MVP, and the MVP forces you to make choices. And then now you have a different worldview inside your application. It's really hard not to get to that place. So there's always code somewhere between the database and the interface. Okay, so FHIR defines interfaces. APIs, if you wish, mostly RESTful APIs, but it doesn't have to be a RESTful API. Okay, messaging or a document API interface, but basically the APIs. They will be provided by an API, by an application that meets the specification, and it's entirely up to the application to do whatever it wants to provide that API. It's qualified a little bit. Like if you say that it's going to be an OAuth client, you've just imposed a bunch of rules on the shape of the application. And you might go and say some other things around storage and so forth that even more constrain the application. But, you know, in principle, we're describing the behavior of the application from outside the application. And it's up to the application what it does. And so it follows that we define the resources for robust exchange. And it's just really significant point that lasts and lasts when you start thinking about using the resources as a storage format. In that we denormalize the data, the resources, to reduce dependency on other exchanges. Because you don't know, you can't always guarantee that they've happened. And if you've been in committee, we fight like cats and dogs about where the transactional boundaries should be. One way of looking at the FHIR design process is to say, we're just trying to figure out a set of agreed transactional boundaries. And in fact, that's the part of FHIR that we fight the most, argue the most about. And so one of the things that we don't follow very carefully is database normalization. Now, database normalization, 1, 2, 3, 4, 5, normal forms, its whole own discussion that we're not particularly getting into, but we don't particularly drive strongly for normalization. So what does that mean in practice? So let's give you an example. Here's a medication request with a code, and it's got a coding on it, and the system this is RxNorm. I just didn't have space for the full RxNorm code, this system, and then there'll be a RxNorm code in the value for the coding. And in fact, you could have multiple codes. You could say there's an RxNorm code, and I'll also give you an ATC code, I'll give you an NDC code, I'll give you a SNOMED CT code because we're also doing IPS, multiple codes, and the codes are provided as a URL and a code pair. Now, if you were actually engineering a storage format, you'd never do that. Yeah, this is crazy. You would define a concept, the key for the concept is the code, and you would store the code directly and just refer to the concept. But we don't do that because we don't know whether you have had an opportunity to make that kind of exchange. And we don't believe that it's viable to impose that kind of exchange on the entire system. And so we store everything as a code system pair rather than a unique key. Even if we did do a unique key, it would be a globally unique key with a whole bunch of qualifiers around its use in order to meet our governance requirements of being global. And it wouldn't be your local key. You would need to have an indirection step in there. So that's a key difference between what we're doing in FHIR and what you would do for natural storage. And a very similar issue arises for references. Here's a medication request with a reference to a medication resource, which is a URL to a path on a server, to a medication 123. Now that might be this server or not. It might be a different server. It might be a relative URL. It might be a symbolic URL in places. It might be actually replaced with a type and an identifier, so you have to sort of have even more indirection. There's all sorts of reasons why we have these levels of indirection built in between medication request and medication that it refers to. But if you're building like a coherent database, that's just a nightmare. You really don't want to do that. You really want to have a direct link, a type of medication, so the medication table with the ID key value of 123. It's the same principle, right? And so those are, for me, the two most obvious ways in which the robustness and resilience of FHIR for exchange in a bunch of circumstances becomes a tax that reaches deep into your operational approach if you use FHIR for storage. So how do you deal with this? So I want to say, before I go on and talk about that, FHIR has a clearly defined schema. It's object orientated. I imposed, which some rules we've always accepted, some rules, for instance, all types are final. There's no substitution unless it's explicit substitution. So there's some things about OO that I decided not to use. It's very shallow. but it's still object orientated and it can be described using MOF or other theoretical object orientation description. So it has a well-described object orientated schema. So we could define a single SQL schema for FHIR, but we don't. We've talked about it on and off every few months for years now. We could define a single SQL schema that everybody should use. But of course, the trick with that would be everybody would have to agree on a single ORM method for mapping from an object to a relational model. People fight like cats and dogs about everything, but that's its own special subject as to what's the right way to do that and how much do you want to normalize your database and where do you want to take your performance hits. I tell you, there's no way we're ever going to get agreement on a single ORM method. But the thing is, ORM methods, although there's like a bunch of them, they're pretty well understood. They're pros and cons, and everybody can point them at one way or another, point them at a FHIR schema and produce their own database with their own flavor of this is the ORM approach I like. So where's the value for us in producing a single database schema? And remember, we already have the bias towards we don't specify anything about the application. And believe me, as an application designer, your database and your application tied together really tightly. And actually, Imop is an interesting study case. So Imop is a standard database. It's a standard database for sharing queries, which is always the driver for sharing, having an SQL schema for FHIR. And then you could share your queries at the schema level. And that's what Imop is for. And in the last probably 2.5 years, Imop has suddenly really emerged as the standard way of doing this out of a bunch of choices. It's finally got impetus. And so we're having a good look at Imop. Now, Imop is dramatically simpler than FHIR. In order to take information from FHIR to Imop, you've got to do a bunch of data work to actually do that transition. And it's simpler. And in fact, that's a value proposition, a big value proposition. I've talked to people who are doing SQL queries on a native FHIR database, and for SQL people, not application people, but SQL people, dealing with a native FHIR database produced by ORM from the FHIR schema is exhausting. Everything is, you just got to chase and chase and chase the data because everything is somewhere else. Because we design the resources to match operational healthcare. And in operational healthcare, context and precision are everything. And we obsess about where does data come from? When did it come from? What's its cardinality? But almost everybody who actually wants to share SQL queries, they're actually doing an analysis, some kind of OLAP analytical work, and they want square data and consistency and accuracy. They want simplified data so they can do that. And for me, that's taken away a lot of the interest in having a single SQL schema. So we don't have a single SQL schema. Instead, we just say, well, we're giving the interface. You can do whatever you want in the background. Right. So behind that curtain, applications can choose. There's basically kind of two choices. You can store your data in a relational database, and then you implement the FHIR API as a series of adapters to that relational database, and you decide how much you're going to denormalize, and you put all your code, all your business rules in your code, and your API does all of the heavy lifting to convert the FHIR API into a set of relational database queries. Now, there's a few features, particularly the reflective features of the FHIR API that are really genuinely hard to implement on a relational database. But they're pretty much optional because they're really hard and because such a lot of really important, genuinely important applications work this way. Basically, any legacy application works this way, that it has its existing relational or quasi-relational database or semi-pseudo-relational something, and there's just a bunch of code to adapt between the FHIR API, whatever it's doing, and the relational database. Or alternatively, you can say, I'm going to store the data as FHIR resources directly, as blobs, documents, JSON or BSON, with a generic REST implementation on CouchDB or Hadoop or whatever, and I'll just use a generic REST stack that knows how to do that stuff really well, or I will write my own REST implementation, but the backend is natively FHIR. And I'll figure out what I want to do with the data on the fly as I handle it. So that's kind of like your two choices, but you don't have to do one or the other. You can mix and match. Like I said, from our point of view, it doesn't matter what you do. So let's talk about the pros and cons of those two approaches as classes of approaches. I don't want to get into the technology about what exactly a relational database is and so forth. I just want to compare the two big picture things. One is I store the data in a relational database, and the other is I just store the FHIR resources directly, and they're my native language through the system. So this slide shouldn't exist in here. Sorry, I will get rid of it. Okay, all right. So when you store resources natively, there's a bunch of different ways to do this. You can store the resources as blobs in an SQL database. Test.fhir.org does that. Happy does that in its sort of native CLI implementation. You can use classic SQL servers that have inbuilt JSON support and use the JSON features that they have. For instance, AidBox does that with PostgreSQL. You use NoSQL servers like MongoDB or Couch or Hadoop. You can use BigQuery, Google do that. Or you can actually store them as RDF. In some RDF store, there's a bunch of them, Gina or whatever, using, well, what looks like the total format and let them do all the stuff in the background. So you can do all those things, but should you? Just because you can doesn't mean that you should. So should you do that? So for me, it comes to how your data requirements are managed. And when I look at applications, including the ones that I've worked on, including the ones I've written from scratch, that are now fully, production clinical applications, there's a sort of a spectrum, a continuum of data requirements process. On the right-hand side, on the left-hand side, is what you might call a classic enterprise information system. The requirements that it expresses are highly characterized. They have bucket loads of documents describing what they are. When you make changes, the changes are proposed, approved, drafted, reviewed, tested, reviewed, approved, tested, approved, tested, you know the process, and it's done by committee. Changes to those kind of systems take years to implement, and the customers that use them assume that they are bulletproof, reliable, that they always behave as expected, and there's a considerable liability on the table around that kind of stuff. Yeah, I've written applications like that and sold them and supported them. There's a different kind of application where, well, it works differently. The data design is effectively delegated to runtime. It's really a framework for a system. The interface specifications change. The customers can change the way they work. There's really not a lot of product development because it's mostly configuration, and the change time frame is in days and weeks. You roll into a new customer and they say, okay, we've got an 8-week implementation phase, and here's the interfaces, that data you are capturing and representing and working with. And you go, oh, okay, well, this is a field we've never seen before, so let's make it work. And so you have change timeframes into days and weeks. And a classic clinical data repository is a good example of that. So the question you should ask yourself is, where does my application fit on that spectrum? And the really interesting thing for me is there is no application that is fully at the end of each of those. applications are spread across the middle somewhere. Some of them lean left and some lean right, but all of them have some highly characterized requirements, and all of them fit into a enterprise institution that says this has to happen, and it has to happen in an implementation timeframe, not a product development timeframe. So turning to FHIR, how does that answer relate to our question? For me, on the left-hand side, you really need to use the relational database. And if you do use the relational database, actually, I'll go back for a slide. If you use a relational database, you can produce a system that is reliable and fast, really fast, compared to a generic FHIR SQL document-based approach, because you control the indexing precisely, you control the fields precisely, and you can optimize for your decisions, and you can test your optimizations and get it right. You will never get something as good and fast as that by just taking a pretty generic FHIR stack. There's going to be, there's a cost. If on the other hand, I've run into customers, I run into vendors doing this. Their support team is scrambling, doing database changes for a customer. They're creating new tables and new fields and existing tables to implement the customer's interface requirements. Terrifying, really, really terrifying stuff that they're changing the, bulletproof database schema on the fly to do implementation work over a period of days. The developers don't even know what's going on. It's bad. It's a bad way to do things. In that case, you're really a lot better off to say, we store things in JSON or BSON or XML or whatever, it doesn't matter. And that's where all of our flex goes. And so in a right side application, I would strongly use a document-based paradigm because it's flexible. But the interesting thing for me is that all the applications being in the middle actually vary typically by module and function. There will be some parts of the application that are bulletproof and, very, very strict and tight. And then there'll be other parts of the application where you need to do all these really weird things. So actually, for the last few years, I've been advocating for a hybrid approach. And my typical hybrid approach is put everything in resources and store the resources directly in some kind of document store. Doesn't matter whether it's SQL database or something else. Index them in Elastic or whatever, it doesn't matter. You just have to manage the deployment issues. But when you have value, where you need to manage, where you need to defend your liability, then suck the stuff out of the resources and store that in database tables of whatever sort that suits you, manage them carefully. And so low value static information and variable information is delegated out to the resources, and the stuff you need to manage, you manage separately. So yes, you have the problem of cloning information in your database. Yes, that's a problem you have to manage. But for me, it allows you to vary in your application as you move across this spectrum to the left and to the right. And then when you need people to do analysis, some kind of OLAP, you say, okay, tell me your problem, and I'll create you a database that's suited to your problem. Now, if you want to do this, if you want to store resources natively, you do want to manage those joins. It goes back to those two examples I showed you before of codes and references. You want to make sure that you have no broken links, and you want to make sure they resolve efficiently. So typically, you will actually modify the format internally. And if you look at the RDF format actually does this. It adds to extra RDF specific properties for resolved local links for references and codings. And I would recommend that if you're storing resources locally, that you do that internally. You resolve the references to have native links so that you can leverage them internally. I would not recommend that you share those externally because that's your private business. And as soon as you start sharing that, you get in trouble because it's your private business. That's my advice. So, should you store FHIR resources as FHIR resources natively? Well, that depends on your requirements. And it should be pretty clear from what I've said that it also depends on your business context, your budget, how much of your budget is front loaded and how much pain you want later, and your technology stack and your development constraints and architecture and team skills. But my strong advice is that you should always consider storing resources natively and storing information out of them in a managed relational atomic indexed form. But whatever you do, your pain will always be around managing joins and referential integrity. And in healthcare, it seems to me that that's deck chairs on the Titanic. You can move them around, but the ship will always be sinking underneath you. Good luck managing that. So I am not physically present, as I said. Oh, so I wish I was, but you can contact me here. And time for questions. And I'm going to start while you're getting your questions lined up with a question that was pre-written before I started about custom resources. Yes, it's pretty common for people using Happy or Vonk or whatever to define their own custom resource because they have a hammer and everything's going to be a nail. We don't define a framework for that in FHIR, but the servers do. But you have to consult the server documentation. Is that a good idea? I don't have an opinion. All right, other questions?
Graham, we have questions here at the audience. In
Okay, great.
Would you go back to the mission slide at the beginning?
Oh, I just stopped sharing, so now I'll have to go back to sharing. Where was I there? The mission, okay. Sure. Did I get the right screen? I don't think I did.
You have the right, yeah, you had the deck up.
I did have, okay. All right. Back to the start. There you go.
Okay, the fourth and fifth bullet points, is there a how missing instead of a what? I heard you verbally say how. And my OCD kicked in. Okay, I'm sorry. And I just want to understand the concept more than I'm nitpicking the presentation.
Yeah, so in theory, we say nothing about what happens inside the application. But in practice, we say a great deal about what happens. And yeah, so it should technically be, we say nothing about how it happens. But look, if you go back through the history of that, or you just, a lurk on chat.fire.org, you'll see that the how and what, they're interrelated.
Okay, so bullet point number 4 would say how, and I'm not nitpicking the syntax. I'm just trying to get the concept. That's
yeah, well,
I see what in
it's
number 4
simpler.
and 5.
I wrote what deliberately.
Okay.
If you really want a simple view, then we say nothing about how it happens, but we say everything about what happens. But it's just, life is more complicated than that. And so I wrote what for both of them to point out that there's actually a tension between what we claim and what we actually achieve.
Okay, so 4 and 5 are right. You're trying to point out the paradox and the tension.
Yeah, that's right.
Yes, okay, thank you. That's what I'm getting at. Thank you.
No worries.
Hey, Graham. I had a question about when you say the hybrid approach, right? So I just want to make sure I get this right. So we store resources natively. And then when you say store information or high value information in a relational database, what is that in your mind? Because I have a sort of a different direction where I was thinking about it.
What happened here?
Is he?
can you hear us? If you can hear us, we can't hear you, so you might want to reconnect.
Right. I'm back. I'm back.
I think you are back.
Oh, that scared you all? I know what happened there.
No, I just thought you didn't want to answer my question.
Oh, well, I don't want to answer your question.
So I was asking, when you say store resources natively, I'm assuming you're still there.
Yep.
Because I can't see you. When you say store resources natively, but store high-value information in a relational database, right? Are you thinking of things that don't naturally fit into the FHIR model, and then because you then would have to use extensions? Or are you thinking of other data? Like, maybe just give us a definition of what high-value, yeah.
Imagine you get a medication request arrives. So you stick the medication request as it is in your database. But you look at it and go, I need a list, a curated list of medications. I know that there's all sorts of weird instructions in the medication resource, medication request resource, that I don't understand all of them. I don't need to, because I'll just show them to the user. But I need to know, I need to index the fact that it exists and what the medication is. So I pull out the code for the medication, look it up in my database, store a reference to the code in my database, along with a reference to the original resource, and now I have a managed medication, but I don't really care what they sent me for instructions, right? That'll be in the resource. So that's the kind of hybrid approach I'm talking about.
Okay, okay. Interesting. All right, thank you.
No worries.
Hey, Graham, thank you for being with us. A question about the hybrid approach as well. So you said we're going to separate or have in the middle kind of compromise between the data that's going into the NoSQL store, something similar like that, and the data in the RDBMS. So we have the assumption that what I'm storing is only FHIR resources. When it comes to data that workflow for the application or things that are not natively FHIR or have clinical concepts, how you manage both things together? That's actually my question was in the first question that was asked before the session, right? So
yeah, you have a hammer, right?
Yeah, so the problem that you're trying to solve is within an organization that you have multiple sections that they not internally in the organizations, they don't talk with each other. So you're trying to unify the data modeling in between them as well, internally, just to make sure that you're able to have all of these blocks talking to each other. But at the same time, each application is very opinionated that they need to have some resources as a FHIR, but some data as well that is specifically data workflows, application workflows that doesn't fit into FHIR. You get my point?
I mean, well, there's a bunch of data that an application deals with that we haven't modeled yet.
Right.
Although it's getting less as we get further into R5. Sometimes you need to look at it the right way. You know, like one of the things that, you know, I miss really comes down to just lists of lists of lists. It's not fun stuff, but it's, you know, grist for applications. But still, there are stuff that isn't in the scope of FHIR. Extensions, custom resources, extreme misuse of basic composition. I wish I had a better answer for you, but I don't. In the end, that's your application problem. But if I was doing an application, I would ruthlessly mix I mean, I don't write applications right now. But if I was, I would ruthlessly mix FHIR resources, custom FHIR resources, and custom JSON. For instance, in test.fire.org, we don't have a user resource. So I use Skim instead. And there's, you know, I just mix and match them. It's the same stack underneath. I hope that's as much as answer I could give you.
Yeah, my second part to follow up on that, if you modeled a custom resource, are you aware of a way to deploy it dynamically without have to compile it or anything? You just deploy it through structure definition maybe? Or what do you think about that?
It's theoretically possible, but it's up to the applications. I sort of half got it working on test.fire.org, but this is for me. It's just for people to test with, and it's not standardized. So I'll leave it to Happy and Vonk. Apparently, Ewart says there's a way to do it in Vonk. I don't know about Happy.
Thank you.
Yes, we do it in Vonk Firely server. You can send a structure definition to the admin endpoint, and you'll magically have your structure definition. You can send in search parameters and so on and so on. To be perfectly honest, it's a nice feature, but it's not used. It is heavy to maintain, so we're actually contemplating about whether we should keep it or not. So that's it.
So if you use it, tell Ewart.
Okay, Graham, we have no additional questions from the, oh, we do actually, never mind.
Hi, Graham. It's Nikolai.
Hey. Hey.
Here. Yeah.
You made it, and I didn't. How about that?
Yeah. Can I make some few notes? Because you guys talking about relational databases, yes, and document databases, but if we look into the bleeding edge of the databases, there is no notion of just relational databases. Now, if you look into progress which is going on in Postgres, in Oracle, and in MySQL, they started supporting kind of native JSON maybe years and years ago, and the progress is quite far that even the new specification of SQL includes JSON operations. So there is no real kind of dichotomy between the, is it relational? If you're talking about relational, you mean flat tables, yes? But the programmers struggle from flat tables for a long time because this object table mismatch, yes? And so I would say there are very interesting ways in the middle. So you could be relational and still store FHIR almost as is with a set of transformation, like you said. But it has support from database, and it could be very efficient. You could use the index system of these databases. So there is no just choice between this, and the progress of databases bring us to the point when it can be, let's say, the ideal hybrid. So you can use the best from the...
I could have said that more clearly, and I agree. And because the stacks are converging, really what I was talking about is how you think about the problem, not which tools you choose.
Yeah, but I would say that in a database community, this problem is well known. It's not belongs to just FHIR, yes? Because most of domains are modeled as aggregates, which can be represented as JSON documents, and everybody asking relational database developers add something, add some support of this. And about custom resources, I think this is not the hammer. This is a way to unify system internally. Yes, if you like the FHIR references and all this stuff, so you want to have a user, you want to have other internal application resources which behave the same way. So this is more unification than just hammer.
That's what a hammer is.
Hey, this is actually a great point. I just wanted to piggyback off of this. And I wanted to see what you think about this, Graham. So I kind of think of the hybrid approach in two ways. One is the hybrid approach that or rather I think of the hybrid word in two different ways. One is what you just said, which is you have a JSON store and then you have a relational model. And that problem, as you correctly said, There's databases now that actually help you fix that technical problem, right? But the other way I think of hybrid is that not everything fits in FHIR, and as soon as you go down the native extension route, you're in big trouble, right? And that's the other hybrid that you almost have to solve in a different way, because you either store extensions, which I feel is problematic, or you store JSON, right? Not FHIR, just JSON.
Yeah.
Or you store all that other information outside of your FHIR store, which is maybe relational, and then somehow join using one of these hybrid new databases, right? So
what do you mean by extension? Is it custom resources or just FHIR extensions?
not just custom resources, but a lot of times stuff doesn't fit within, like cleanly within the resource, because you either have an existing data model that you're trying to fit within FHIR, and you're trying to keep your internal, let's say, local coding, or you're trying to keep, I don't have a great example off the top of my head, but internal mnemonics usually, internal location codes, things like that. And those usually get relegated to an extension, right?
And here come the first-class extensions.
Yes.
Which is another useful transformation when you store data natively in database. Yeah.
So I guess the question that I was, or not even question actually, just your opinion, was that these are the two ways that I've thought of, like, you know, here lie the dragons of, like, basically the hybrid FHIR, storing data as FHIR approach, right? And one of them is somewhat fixable, as you said, which is use a database like BigQuery or something like that, that lets you store, you know, hybrid.
Not just BigQuery. Oracle has support.
I know,
Postgres has support. Yes.
Yes. Totally agree. And then the other hybrid problem, which we didn't really talk about, is what happens when you have sort of the custom data. Anyway, this has gone on too long. So just wanted to see what you've thought about, because I know you've talked about the other side of this in other previous blog posts.
I don't have any good advice for those kind of difficult questions. I'm sorry. But I will say that no matter how much this appears to be well-explored space, I get asked about this constantly. And when I say you should have some kind of hybrid approach, people look at me and go, does anybody else do that? So maybe, Nikolai, you should go on some kind of evangelization campaign.
Hi, Graham. Maybe one more question for the people with experience in the hybrid approach. I think there are like two parts in the hybrid approach. It's like storing objects close to your table, but also the schema enforcement. Do you like enforce the schema on write, or you keep the schema flexible for the object part? And is it possible to do like schema on read in the Postgres and in Oracle?
Well, I expect that you'll have business rules that fire on any incoming data, and that'll include validation to the level that you desire. Some people in national EHRs and trading systems with billions of messages a day run the full Java process validator on everything, which is not what I wrote it for. But other people just go, no, I will check that the codes are valid and so forth, the information I'm going to index. But I'm assuming that you do the validation you need on every piece of incoming data.
Yeah, and I can add some notes. Yes, this is the essence of the problem when the people moving from flat tables with a hard-coded schema to something like JSON documents, because the data are variadic. And even this, if you look into observation, it essentially multiple different entities, yes, like blood pressure, completely different from, I know, urology analysis or something like this, yes. So essentially, it's going to be different tables, yes, but you generalize it to one entity, and then you slightly relax the schema in database, and it gives you this open world idea, yes. You can write more generic system if you can relax the schema, and usually you move the schema outside of the database, and that's most high-load system do. They never use like foreign keys or additional constraints. They do these rules on the application level. But potentially, yes, it's possible. Even now, you can write constraints in database which can constrain some pieces of the schema. But then you can find against this idea that potentially you can store kind of different entities in a one table with the different fields because they have different profiles. So it's better to move the validation piece outside of the database. Yes, and you have tools to do this, I mean, in current database.
Yeah, I think it comes down to the high value information, maybe. Like the less value information, you can do less schema.
Usually you put constraints on what you want to index and search. Yes.
Yeah.
And that's not everything. And you can do it conditionally. If it's this resources of this profile, then you create the kind of partial index on it. And you enforce specific constraint on it, like data format. Yes, so it can be parsed by database. So not everything. But you get this flexibility doing on-fly, new profiles stored in the same schema. So that's the dream of the developers. Yeah. That's why we hate flat tables. Yeah.
Yeah. Thanks for the input.
All right, thank you. We've gone just slightly over time, so we'll have to stop questions at this point. But if you have any additional questions, you can put them in Whova, and Grahame has already, I believe, started answering some.
Oh, yeah, I'm answering them.
Yes.
Thanks, everybody, for listening.
All
Maybe
right,
I'll see you
thanks
next
so much,
time.
Grahame.